Okay, girls, this video will help you with chapter 1, lesson 1. And I'm going to spend most of the video on this page. Just remember how I had the information organized under each header. So if you're looking to find this in the book, make sure you go to wherever the specific header is. So we're going to start with our essential questions, but we're going to answer those last because they're easier to answer once you've read the entire section and understand all of the information. So kinetic and potential energy, these were pretty easy. So energy is the ability to cause change. What is kinetic energy? These were found in the green box on page 6. And energy an object or particle has because it is moving. And then what is potential energy? Stored energy that happens because two objects are interacting. So objects always are going to be pulling on each other, and that's the interaction that they're having. They're changing or causing change on each other. How do you calculate mechanical energy of an object? So you take the kinetic energy of the object plus the potential energy of the object, and that will give you ME, and that's just short for mechanical energy. So please notice that we're looking at the mechanical energy of the whole soccer ball and the potential energy of the whole thing. So in the book they were using the example of the soccer ball. So we're taking a look at the kinetic energy of the kinetic and the potential energy of the soccer ball, not the particles of the soccer ball. The next one, what is thermal energy? So this actually wasn't in the book, but I wanted to see if you knew what was going on here. What does the word particle mean? Particle also means atom. So when they talk about particles, they're also talking about atoms. And this also wasn't in the book, but I wanted to make sure that you remembered it and that you were thinking about it while you were reading this section. What are the 3 states of matter? So solids, liquids, and gases. And if you take a look in the activity book, I go over a lot about solids, liquids, and gases. So if you needed a refresher about solids, liquids, and gases, make sure you take a look at the activity book. Why do particles in a gas have more kinetic energy? So atoms in a gas move faster. That's why. They actually move so fast that we can't see them. But the particles in a solid, they move so slow that we can actually see them moving. Or they look like they're moving so slow they look like they're not moving. 10. Why do particles in a gas have more potential energy than a solid? That's because the average distance between the particles is greater. So the distance between the particles in a gas, huge, long distance, but not so much in a solid. So how do you calculate thermal energy of a material? So I'm looking at the kinetic energy of the particles, not the whole material, but I'm going on a real small atomic level and looking at the particles plus the potential energy of the particles. And that's how you calculate thermal energy. The next one, what is temperature? Most people did really good on this section because it was really easy to read and the information was organized really great. So the first thing that I wanted to make sure that you knew or remember is what an average is. When I take the average, I add up the number. So I gave you 3 numbers. So I add up the information that I'm given and I get a total, and then I divide how many pieces of information I was given. So here I gave you 3 pieces of information, 15, 40, and 5. That gave me 60, and when I divided by 3, I got 20. So when I talk about temperature and we're talking about an average, we are taking a look. So this is what temperature represents the average kinetic energy of every particle that makes up the material. So we're looking at every particle in the material. We're going to add up how fast it's moving, and then we're going to divide how many particles are in the material. And the greater the average kinetic energy of the particles, the greater the temperature. And the opposite is true. The lower the average kinetic energy, the lower the temperature is going to be. And this section right here, where we were talking about measuring temperature, you can't really add up the kinetic energy of every particle in a material, so we use a thermometer. And the common one that we use is a Bob thermometer. That's the one that we would actually use in class. Then this information, so actually I'm looking at these questions right here, 14 through 19. They were really easy to see in these two paragraphs. So this is where I found that information. The scale, so on a Fahrenheit scale, water is 32 degrees. It freezes at 32 degrees, boils at 212. On the Celsius, it freezes at 0, boils at 100 degrees Celsius. And then on the Kelvin scale, 273 K is where it freezes and it boils at 373 K. And the lowest possible temperature for any material is 0 degrees K, and that's called absolute zero. So we've just answered, looking at that paragraph, looking at those paragraphs, we've answered 14 through 19. This is something that I wanted to make sure that you understand. So if I write down Celsius, Fahrenheit, and Kelvin, and I write down the temperature that water boils, I got 212, 100, and 373. And then if I write down the temperature that water freezes, 32, 0, and 273, this means that all three of these temperatures are equal. So 212 degrees Celsius is equal to 100 degrees Celsius, which equals 373 degrees K. So make sure you understand that these things, make sure that you understand that these things are equal, because they're all the temperature at which water boils and freezes. And this next one says, what temperature scale do we use in the UAE? It's always going to be in Celsius. This is also the one that we use when we take measurements in class. We use Celsius. Fun fact, the United States uses Fahrenheit. I do not know why we have to be so different. All right, the next one says, what is heat? So I'm under the what is heat header. So what is heat? It's the movement of thermal energy from a warmer object to a cooler object. The fact that thermal energy naturally moves from a warmer object to a cooler object, that is something that you need to make sure you remember, because it keeps coming up in this entire chapter. The next one says, describe how someone's cold hands are heated by holding a hot cup of tea. So the best way for you to answer this question was to take a look at this picture. So the tea has the thermal energy, and the thermal energy is going to move from the warm tea to her colder hands. So this is where they discussed it. The girl in figure 5 heats her hands because thermal energy transfers from the hot cocoa to her hands. So this is the answer to number 22. What is a rate? This actually wasn't in the book, but when they were talking about heating rates, it was important for you to know this. What is a rate? That's how fast or slow something happens. So when we want to talk about how fast or slow thermal energy is moving from a warmer object to a colder object, it depends on how different the two temperatures of the objects are. So if one thing is really, really hot and one is really, really cold, they'll transfer thermal energy a lot faster. But if one is not so hot and one is not so cold, they won't transfer thermal energy as fast. And that's what we just talked about here. How fast or slow does heating, how fast or slow something heats depends on. And then what is equilibrium? Equilibrium is when two or more things are equal. And that's what helps with this last question. It says, when does the transfer of thermal energy between objects stops? When equilibrium happens. So that means when they have equal amounts of thermal energy, they'll stop heating each other. When they have equal amounts of thermal energy, no more thermal energy will be transferred because they're the same temperature. All right, back to our essential questions. So the first one was, how are temperature and kinetic energy related? So temperature to get temperature, you add up kinetic energy of all the particles and you divide by the particles. But in order to get the temperature, you need the kinetic energy. So that's how they're related. You need to know the kinetic energy to be able to calculate the temperature. That's how they're related. And this is average kinetic energy. The next question says, what is the difference between heat and thermal energy? So thermal energy is something that you calculate. It's something that you can measure. That's the kinetic energy of the particles. That's what K means, kinetic. And potential energy, that's what P means, of the particles. So this is something that you measure. But heat is just the movement of thermal energy. It's just the movement of thermal energy from warm to cold. It's not a measurement. Well, you can take the temperature of something, but when you take the temperature, this is what you're taking. So heat is just the movement of thermal energy from warm to cold. So make sure you know this thermal energy is something that you measure, but heat or heating is just the movement of thermal energy. One thing that was really important that you need to know is how two things could have the same temperature but different thermal energies. And that was actually talked about in this paragraph right here, thermal energy and temperature. So paragraph number 4 on page 8. And I just wanted to show you this because this is going to come up on the test. So let's say I have ice and water. And I had a piece of ice and it starts to melt and to become water. So now I have ice water. So I have ice that's in water. So in order to calculate the thermal energy of the ice, I take the kinetic energy of the particles plus the potential energy of the particles. In order to calculate the temperature of the water, I also take the kinetic energy of the particles plus the potential energy of the particles. So when I have the ice water, and the ice and the water are the same temperature, temperature means that they have the same average kinetic energy of their particles. So these two things could be the same, and they would have the same temperature. But remember, in order to calculate thermal energy, I need two things. I need kinetic and potential energy of the particles. So even though the ice and the water have the same kinetic energy, their particles have the same kinetic energy and they're the same temperature, because one is an ice, it's a solid, solids have less potential energy. And because one is water and it's a liquid, liquids have more potential energy than solids because there's more space between the particles. So this is what the particles in the ice look like. Not a lot of potential energy, but this is what the particles in the liquid look like, more potential energy. So that's how two things could have the same temperature. That's because they have the same average kinetic, they have the same average kinetic movement for their kinetic particles, but because they're different states of matter, they will have different potential energies, and that would mean that they wouldn't be the same thermal energy. This one would be lower and this one would be higher. And that is something that you need to know because there is going to be a question on the test where you have to explain that.